Hello my dear students, welcome back to NEET World. So today we will be discussing exclusively EAPCET PYQs. Okay, so now the first question here is from structure of atom. See this is from graphical representation of orbitals. Like see the graph between variation of probability density psi square and distance from the electron from the nucleus, that is R, okay, is shown here. So which orbital the graph represent which orbital exactly? See we have A, B, C, D options having 1s, 2s, 3s, 2p orbitals. So now how can we identify this? Very easy. Look at here. Whenever you are doing this, we have the radial curve. This is having radius now here. So now here psi square versus R means, see, just let me change the color first. Yeah, so now just find how many times this graph is touching this R, like distance axis here, x axis here. One time now, so this is having one radial node. So what is the radial node formula? Radial node equals to n minus L minus 1. So where n is principal quantum number, L is azimuthal quantum number, and here 1. So now n is how much? So for, we don't know, radial nodes are how many we have? Here we have 1. Okay, so now, so look at here, graph is starting from maxima, right? So now look at here, for 1s how many radial nodes are possible? So just find radial nodes possible for 1s. So 1 now, so n value 1, L value is 0 and minus 1. So radial nodes is 0 for 1s. Whereas for 2s, so 2 minus 0 minus 1. So radial nodes are 1 here. So this is the perfect option, or correct answer for this question will be option number 2. If you want, you can check. For 3s you will get 2 radial nodes, okay, and for 2p it will be 0 radial nodes. So n value is 2, L value is 1 minus 1. So it is 0 radial nodes for 2p orbital. So what is the suitable answer for this question? Just option number 2. Hope this is clear. What is the best approach you can say? First of all, whenever you have a graph, look at here, how many times, like forget about starting point and ending point. After that, how many times in between the 2 points, starting and ending point, initial and final point, how many times it is touching this x axis? That many nodes are there here. Okay, so here how many times it is touching? 1 time now. So 1 radial node. So 1 radial node corresponds to which orbital in the given 4? That is your answer here. So the given answer is option number 2, 2s orbital is having 1 radial node. So this is how the simple way you can answer. Okay, yes, let us move forward with a few more questions. Okay, see now, so tell me in the chat box, those who are watching the live session, so just tell me in the chat box psi square versus R I am drawing. So now I just wanted to represent it like this. It is something like this. So now tell me how many times it is touching? So 1, 2, right now. So 2 times means 2 radial nodes. So 2 radial nodes corresponds to which option here? So it will be option number C if I give a graph like this. Hope this is also clear, right? Let us move forward with few more questions. So look at here, we have a question from equilibrium. Read the question. The solubility product of AgBr, okay, having solubility product, the solubility of AgBr having solubility product 5 into 10 power minus 10 in 0.2 molar NaBr solution equals to, they are asking what is the solubility S in presence of solubility of AgBr in presence of NaBr. So this is a concept called common ion effect in solubility. Okay, just follow the session for few more minutes, you will get it easy. Okay, so AgBr is a sparingly soluble salt. Okay, it will dissociate or it will soluble in the water like this. So it is a weak electrolyte, or I can say weakly soluble, like slightly soluble, sparingly soluble, so that it will dissociate it like this first to some extent. Okay, so now initially only this is present at initially time 0, there is no solubility. After some time what happens? After some t time, so some of the amount of this AgBr will get dissociated now, I mean soluble now, so that will be S and S here. So what here, what is the product of solubility here? Ksp equals to concentration of Ag plus into concentration of Br minus. So concentration of Ag plus into concentration of Br minus. Okay, like this you can take. Okay, so now look at here, what I can make. see AgBr. So if there is no common ion effect, I just need to multiply S into S square I can say as a solubility product. But here they are saying NaBr is there. See, NaBr is a strong electrolyte now. So whenever this NaBr is present along with this electrolyte in the beaker, we also have concentration of Br minus ions from this strong electrolyte, from this NaBr. Okay, so NaBr concentration, Br minus concentration is how much here? It is 0.2. So what is the total Br minus ion concentration in the beaker? So we have in the container S plus 0.2 right now. So it means whenever, just remember, whenever you have a common ion from strong electrolyte, therefore the ion, the common ion which is coming from weak electrolyte will be almost negligible. The concentration of weak electrolyte ion coming from weak electrolyte is almost negligible when we compare with the concentration of that ion from the strong electrolyte. So this concentration becomes how much? It is almost 0.2. Okay, so now I am just writing here concentration of Ag plus as S and concentration of Br minus as 0.2. Okay, that's it. So what is the Ksp given for this? 5 into 10 power minus 10. That's it. You got the answer. So now look at here what I can make. So S is equals to what I can make here, 5 into 10 power minus 10, and if you write it here, so you just write here 0.2 as 2 into 10 here, that is 50. So this will be 25 into 10 power minus 10. That's it. This will be your answer. Okay, I hope you got what I am explaining here. So our option number B will be our perfectly correct answer for this question, right? Yes. If this is clear, just tell me in the comment box, clear sir. Yeah, so you just try to interact with your teacher, then you can able to get maximum from the classroom. Okay, yes. Okay, yeah. So is that clear or not? Yes, clear, right? Right. Next, yeah. So look at this. This is from periodic classification, or I can say oxides. Okay, so identify the set of acidic oxides. See, whenever you have alkali metals and alkaline earth metals, the oxides of those elements will be always basic except beryllium oxide. Other oxides are always basic, remember that. Okay, and when it comes to p block elements, in their lower oxidation state they might be neutral or amphoteric, but in higher oxidation state they can also be like in higher oxidation state they can be acidic. Okay, yes. Look at here. So look at here, we have manganese with +7 oxidation state. So metal in their lower oxidation state can be a basic one, but in their highest oxidation state, especially for manganese, +7 is the maximum now. So here it will be acidic. Okay, again chromic oxide here, chromium +6, again maximum, this is also acidic. Again vanadium, this is also +5, so this is also maximum oxidation state of vanadium possible is +5, so this is also acidic oxides. So all the option D will be having all of them are acidic oxide. Okay, so whereas CO, see carbon having 2 oxides possible, CO and CO2. Out of this, CO2 is acidic oxide, remember, because it is +4 oxidation state, remember maximum oxidation state, and this is +2 oxidation state. So this is neutral oxide. So these compounds are neutral oxides here. So what is a suitable answer for this particular case? So this will be option number D. Okay, if I ask for the same question, identify number of basic oxides, means how many basic oxides are, like set of basic oxides in the given 4 options, which is a perfect answer. If I ask the set of basic oxides is, means, so your option number 1 will be for set of basic oxides here. Okay, see all questions are PYQs, either repeated once or twice like that, or in the different exams. Okay, right. If this is clear, let us move forward. Yeah, again one more simple question here we have from electron gain enthalpy. Tell me, so which is a proper indication of electron gain enthalpy? How can you define electron gain enthalpy? The amount of energy released or absorbed or enthalpy change when an electron is added to neutral gaseous isolated atom, right now. So now these atoms are there here, so this is in solid form, remove this atom here, always in this process that species should be always in a gaseous state, gaseous, so this is also solid, remove. After that electron should be added. So here electron is added here. So this is a process, I can say electron is getting added. So electron gain enthalpy representation is perfectly indicated in first option. Okay, so whereas what happens in option number 3, this is an indication for what? Ionization energy. This is for ionization energy, this is for electron gain enthalpy. Okay, remember these things. Hope this is clear, right? Okay, if these things are clear, just click on the like button dear. Okay, those who are in the live sessions, just things are clear here, just click on the like button, and if you are new to this channel, subscribe the channel first, right? Yeah, let us move forward. Yeah, see again we have an interesting question from dipole moment concept. Look at here, which are the following molecules among the following are resultant having non-zero dipole moment. See, how can you identify non-zero dipole moment? If the bond polarities are exactly opposite, since they are vector quantities, they will cancel out each other, therefore dipole moment in that case will be 0. So look at here, the chlorine here electronegative than this carbon right now, so the bond polarity will be upside, and here chlorine here more electronegative, the bond polarity will be downside. So they are exactly opposite to each other, so mu value will be 0 in this case. They are asking non-zero. Okay, so in this case also cyanide, so cyanide is a sp hybridized species now, like this nitrogen. Okay, so it is a linear, here also linear groups, like exactly opposite, mu here also 0. Okay, but in this case if you observe, the scenario is different. So just look at the structure they have given. See, oxygen here having like whatever the structure we are writing for water. See, we will be write for water structure will be like this now, like a bent shape we are writing like this right now. So due to the presence of lone pairs, it is having a V shape or bent shape right now. So due to this reason, what happens, same concept apply over here. So hydrogen will be like this, lone pairs like this. So the here also oxygen, okay, and hydrogen if I write here, see they have different directions. Dipole moments are in different directions like this, see, towards this side, like one like they are not cancelling out each other right now. So mu is not equals to 0 in the third case as well as in the fourth case. This SH also having similar kind of story here, right? So what is your answer? 3 and 4. Where do we have 3 and 4? So first option A will be your answer for this question, right? Yes. If this is clear, right, just tell me clear sir in the chat box. Yeah, let us move forward with few more examples, right? So look at this question again from thermodynamics. So the spontaneity or non-spontaneity based concept, it is Gibbs free energy concept. See, in a chemical reaction is known to be, if a chemical reaction is known to be non-spontaneous at 298 Kelvin, but spontaneous is 350 Kelvin. It means the spontaneity of reaction is taking place at higher temperature. Therefore, then which among the following condition is true for the reaction? Just look at here, very easy. See, just take this equation delta G is equals to, we need to know the spontaneity of a process is determined or explained or given by two factors. One is enthalpy and another one is entropy. Enthalpy should be negative and entropy should be positive, then that particular process will be always spontaneous. Okay, if they are in different manner, the one which is dominating factor will decide whether a reaction is spontaneous or not. So delta G, which will be giving the relation between delta H and delta S, okay, like this, T delta S. So from this, what they are saying, reaction is non-spontaneous at low temperature. Okay, it means delta H is positive, so delta H by delta S you take. So the relation between delta H by delta S to temperature you need to compare here. See, at lower temperature it is non-spontaneous. It means at lower temperature might be delta H is positive, okay, and delta S is negative. Therefore, yeah, delta S is positive, delta H is also positive. Now what happens? So this value, if you observe, if this value is greater, delta H value is greater, if this is the condition, then that will be non-spontaneous at low temperature. Okay, if I make, see, I told that this is positive and the already negative sign here, for a spontaneous process delta G has to be negative. In order to make delta G negative, what are the possible ways we can make? Either you put delta G positive or delta G negative, like that we have different possibilities right now. So as per the condition, if delta H is positive and delta S is also positive, okay, what happens? This second term, positive minus negative, it will be negative. So this is negative, but I want total term to be negative. It means delta G has to be negative. It means the second term T delta S to be dominating factor here, then only reaction becomes spontaneous. It means the second term value should be greater than the first term value because it is positive. Okay, so now if delta H by delta S value is greater, then that will be non-spontaneous when I compare with the temperature. If it is in this manner, T is greater than delta H by delta S, okay, then the reaction becomes spontaneous if delta H is taken positive and delta S is taken also as positive. Okay, if this is a scenario, then at higher temperature it becomes spontaneous, at lower temperature it will become non-spontaneous. See, as per the data they provided, so this is the scenario now. At low temperature 298 it is non-spontaneous, but by increasing 350 Kelvin it is becoming spontaneous. It means high temperature favoring the reaction. It means this is the condition, delta H is positive, delta S is also positive, so delta G becomes negative, okay, at 350 degrees Celsius. So what is your answer for this? Option number C will be perfect answer for this question, right? Yes. Let us move forward with few more questions here. Yeah. Now look at here. Again, if you are new to this channel, I was already discussing, I was making the videos on all the chapters of PYQs, like thermodynamics were done in the last few sessions, equilibrium is also done, okay, structure of atom is also covered, chemical bonding is covered, okay, maximum chapters are over. Just go through the playlist, you can have like whatever chapter you want, okay. If any topic is not covered, just write in the chat box, comment box, I will be looking into it and I will be covering that in the upcoming sessions. Feel free to discuss with your teacher here. And if you are new to this channel and if you wanted to connect with us, just contact through the mobile numbers given in the description box, or you can join our Telegram group, link is available in the description box, okay. Yes, okay. Now look at here, observe the following reactions, okay, identify in which the entropy is increasing, okay. Look at here, entropy is increasing means for a given reaction, just consider given chemical reaction, if delta Ng, it means number of gaseous products minus number of gaseous reactants. If greater than 0, then you can say entropy is increasing, that's it. Okay, look at here, in the first process this is solid, do not consider solids. I told only gases, so here it is becoming gas right now. So delta Ng, gaseous product minus gaseous reactants. Gaseous product is 1, gaseous reactant is 0. So delta Ng value is 1 minus 0 means it is positive, greater than 0 now. So entropy is increasing in the first case, okay. And see here both are gases, but here we have 2 gaseous particles, here only 1. So it means what? Entropy here also increasing, in second case also increasing. In third case, liquid converting into solid. See, always remember entropy will be more in gaseous state, then this liquid state, and least will be in the solid state. As in the solid, particles are arranged with closely packing right now, but whereas in the liquid and gaseous state they have ability to move here and there, the randomness increases. So gas has maximum randomness. See, liquid is converting into solid means randomness is decreasing, so entropy decreases here. So 1 and 2. So option B will be your answer for this question, right? Right. Next. So tell me this process, the favorable conditions for the reaction to occur in the forward direction. See, this is a reaction given, it has to move forward. What is a favorable condition? From Le-Chatelier principle you can answer this. See, during the process heat is released. Heat is released means it is an exothermic process. Delta H is negative. Okay, negative means heat is releasing means system's temperature is reduced right now. If heat is coming out of the system during the process means the temperature of the system decreases now. So it means the forward reaction is favored by decrease in temperature. It means low temperature favors forward reaction. So I can say low temperature favors forward reaction. So option A, B are having low temperature. Now what is the effect of pressure here? See, here you have how many gases reactants? 1 plus 1 by 2. Okay, you have 3 by 2 gaseous reactants and gaseous product is 1. So number of gaseous species are where we have reactant side is more now. So effect of pressure will be more on reactant side. If we increase the pressure, so effect will be more on reactant side, therefore equilibrium favors forward. So in order to make the reaction forward, you need to maintain high pressures. Okay, so what you need to make? High pressure should be maintained, then equilibrium shift forward. So low temperature, high pressures favors forward. So option B will be a perfect answer for this question, right? Yes. Next. So tell me for this question, what is your expected answer for this? So tell me, pH of an aqueous solution of NH4Cl, ammonium chloride. How can you say aqueous solution of ammonium chloride? So ammonium chloride is a salt made up of strong acid, weak base. How I am saying strong acid, weak base? See, ammonium chloride. Upon hydrolysis, ammonium chloride. Upon hydrolysis, it means upon adding water, what happens is, see, in this is the cationic part, this is the anionic part. Even from water also we have H plus ion and OH minus ion. So the cationic part will pair up with this anionic part of water. So just take NH4 plus OH minus, okay, and here Cl minus H plus. So we are going to get H plus and Cl minus. So here you got a weak acid, weak base and a strong acid, therefore resultant solution will be acidic because strong acid is dominating now. So what happens if the solution is acidic? If the solution is acidic, pH will be, how the pH will be? pH will be less than 7, because the pH scale acidic range is below 7 right now. So it will be less than 7, pH will be less than 7. So option C will be your answer. Okay, so to the same question, I just wanted to the same the similar concept, I just want to make one more question here. So I have something like this, sodium acetate I am giving. The aqueous solution of sodium acetate will be the pH of similar one I am giving, pH of an aqueous solution of sodium acetate is what? Whether pH will be greater than 7, same options I am giving for this question. So tell me your answer in the chat box, anyone. I want answer for this question where pH of an aqueous solution of sodium acetate will be. Which is the suitable answer? Whether equals to 7, greater than 7, less than 7. Just what to need to do? You just add this to the water. Okay, so in the water we are going to get H plus and OH minus. From here Na plus and acetate ion. So the negative part here will pair up with the cation of water and positive part will pair up with the anion of water, that is OH. So it becomes NaOH and acetic acid. Weak acid, strong base. So strong base is dominating here now. So the resultant solution will be basic in this case. So pH will be greater than 7. Okay, hope this is clear, right? Let us move forward. We have a question from hydrocarbons. Yeah, tell me. What are X and Y respectively in the following reaction sequence? We have an isopentane treated with KMnO4, we get X upon dehydration gives Y. So identify X and Y. Okay, easy here also. Yeah, look at here, what is the structure of isopentane? Okay, this is the structure of isopentane. So upon treating with KMnO4, KMnO4 is a strong oxidizing agent we know, but where it will oxidize, what is the change it will make? See, KMnO4 does not react with alkanes, simple alkanes, but whenever you have a tertiary hydrogen, tertiary carbon containing hydrogen, so that will be getting oxidized to respective alcohol. Okay, so this hydrogen, whatever the tertiary hydrogen is there, that one will convert into alcohol like this, like this. We got OH group there. Okay, this is our X here. So this X upon dehydration. So dehydration means removal of water. So from where you need to remove water? So what is the best possible way? See, always remove water in such a way that you are going to get a internal alkene. That means you should get a stable alkene. If you add if you remove hydrogen from here or here, you are going to get a double bond like this. That is terminal alkene. If I remove a proton from here, you are going to get a double bond here. So these are called internal alkenes. What is this? These are internal alkenes. Internal alkenes are highly stable than the terminal alkene. Why it is more stabilized? Because the alpha hydrogens present for internal alkenes are stabilizing this double bond. Okay, that's why. How it will be? By hyperconjugation effect. Okay, by alpha hydrogens of this double bonded carbon, the pi electrons will be getting stabilized by conjugation, by hyperconjugation. Okay, more is the internal alkene, more is its stability. Okay, more are the alkyl groups around the double bonded carbons, more is its stability. Okay, right. So what is the major product formed here? This is the major product. So option 1, if you observe, you have the answer like that. So your option number 1 will be perfect answer. Okay, right. Clear now? Yes, clear means just click on the like button first. Yeah. Let us move forward with few more questions. Yeah, look at this. Molarity of 50 ml sulfuric acid is 10 molar. If the solution, if the density of solution is 1.4, then calculates its molarity. Okay, so what you are going to do? Just tell me what you are going to do. See, molarity is given. So how this density affects? See, 50 ml, so multiply that so that you will get weight of the solution. From that you can give a try. Yes, if you are, just give a try. If you are unable to do this, just watch my videos on concentration terms. Okay, if not, you just write me in the comment box. I am going to explain that in the upcoming sessions. So take it as a homework question. And here we have one more. Yes, this question, this particular one, I have discussed in the last session. Okay, the last session. If you haven't watched that, you can watch. First of all, give a try for solving this. If you are really facing difficult, then you can watch. Okay, so watch my previous session if you are unable to do this question. Yesterday's session, go through the live sessions of this particular channel where you can access all our previous live sessions. Okay, yeah. Next. Even all these questions were discussed in the last class itself. Just give a try. I just wanted to show you those questions. Yeah, just look into these questions. If you are really facing to solve these questions, then you can watch the previous slide. Okay, if you are able to do, no need of watching that. Okay, yeah, this is purely to make you feel comfortable or make you to create a learning environment. Okay, yes. Thank you for watching. Stay connected with this NEET World channel, and if you have any queries, you just write in the chat box. We will address them. Okay, thank you for watching.